Good evening, students. So in today's video, we will be seeing how we can implement converting infix expression to postfix expression. So in my previous video, people have seen with an example. So if you have understood, please watch that video first and then watch this video, because you will understand this program only when you understand the program, only when you understand the example which has been solved. So coming to this program, so first let us see what are the functions we need. The first thing is, we know, all of us know that we need main function, right? So when we compile the program, any program, it is going to start from the main. So from main, we are going to call the function called convert IP. So which in turn calls this convert IP, where we are going to pass two parameters, that is infix and postfix. Now, when we, after passing here, again in convert IP, that is function, we will be calling push function, will be calling pop, and also precedence function. Now, what happens is, whenever we call push function, this is going to call in turn this push function, completes its task, and again resumes back to the same place. Similarly, whenever pop is called, it performs its operation, whatever the pop has to perform, and again resumes back to the same place where it stopped. Similarly with the precedence. So all this push, pop, and precedence function is being called within convert IP function. Now let us see how this, let us first see the convert IP. So altogether we have how many functions? Push, pop, precedence, and convert IP, and also the main function. Now one thing everyone should remember is, since we are calling push, pop, and precedence function, we need to write first, before convert IP, we are supposed to write push, pop, and precedence. So that is, first we are going to write this in this way. So we already know that this is my push function. Push character main. Yeah, I'm passing M character and stack plus plus toss. So before we, you need to understand first what is that I'm going to call from the main function. So let us see what is there in the main function. Yeah. So this is what we are going to write in the main function. So what is the input? The input will be my infix notation. It could be A plus B star C. I'm taking a very simple example, A plus B star C. So this is the input function which is stored in infix array. Infix array, which is, we have already declared it. Similarly, convert, once we give the input, now we need to process that input. So we are calling the function convert in infix comma postfix. So infix is the parameter which we are passing. Why we are passing? Because there is a infix notation. So this actually will be stored in place of infix. Now why we are sending postfix is, we want to store the converted expression to postfix. So that is why we are passing two parameters. Now from here, the functions will be called. Now let us see how this convert function will work. So this is the first, this is convert IP. Let me start with the convert IP. So if you have seen my example, I'll take a very simple example, A plus B star C. Now assuming that this is being stored in an array. Now this is stored in array. 0, 1, 2, 3, 4, and last one will be the null character. So by default, it will a string at the last character will be stored as null character. Now this is stored in infix array. Now first, as I told you, my initial step, if you remember, we are pushing hash. We are just pushing hash in the stack, right? If you remember the tabular column, it is very clear. Now, since we have to process each and every character of infix array, so we need to write it in a for loop. So in for loop, we will start from, since it is starting from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, and ninth one is the null character. So now we have to process character by character. So the best way is to find the string length, so which comes to 9. So for I is equal to 0, I less than str len of infix. So when you calculate the length of the string, we will be getting this as the output of this str len will be 9. Sorry, it could be 10. Okay. So now yeah. Sorry, the str len of infix will be 9 because we have 9 characters. Now, if you want to process one by one, now first you have to extract the first character in infix of infix. So how we can do that is infix of I is nothing but first time it is I is 0. What is infix of I? That is open parenthesis. Now open parenthesis is first stored in sim. Now when we see this switch sim, what will be, because symbol is a character type. So symbol, now as soon as it sees, it will check with all the cases. The first case itself is open parenthesis. The moment we see the open parenthesis, as we have seen in the example itself, the open parenthesis without checking for what is there in the stack will directly push into the stack. So that's what we have done here. We have just pushed into the stack symbol. Now we have pushed into the stack. This is case 1, right? Now we will say yeah. Next infix. Now what happens once this is done? It will break. The switch case is breaked, and again it will go for the next character. So what is my next character is A. Whenever we see A, it will check with all the cases. Now we have seen this case. Now next is open closed parenthesis. Next is precedence, that is all the operators are being seen. This is the third case. And fourth case is if it is uh, an operand, then what we do is, since now we have considered operand that is A, so now A is directly stored in postfix. Since J is initialized to 0, we have an initial, if you see here, we have initialized it to 0. So what happens is in J plus plus, that is none of the cases is true. It is just an operand. So once it is operand, we have written in default that postfix J plus plus. So in postfix of 0, A is stored. Fine. This is, we have shown it in the example also directly. If it is A, we directly store it in postfix. So in postfix of 0, A is stored. Now again coming to next. Now this is done. Now close off switch, close off. Now it is close off switch. That's all. Now we will see again which is the next character to be considered. That is plus. Now infix of 2. Now it is infix of 2. Infix of 2 is nothing but plus. Now sim stores plus. So now plus, since symbol is a character, again it will check. Is it plus? No. Is it closed? No. Now it will check with this. Now in this case, we have one condition. We have one while loop. Now if you see here, precedence of symbol and precedence of this. Precedence is nothing but one function is called. What is this precedence function will do? The precedence function will take care of returning if it is the power could be either cap, or we can sometimes consider, we also mention it with the dollar sign and also the up arrow. So any one of these indicates it's a power. So now case power means it is going to return 4. That is why the return type is integer. Now if it is either slash, that is division or multiplication, or it could be modulus, it will return 3. So if it is plus minus, it will return 2, and if it is open parenthesis, closed parenthesis, or if it is hash, it will return 1. So this we already know the precedence rule. So now this will be called only in the case of an operator. So if you see here, now which is the case we have considered this now. So we are encountering this while precedence of symbol. Now precedence of symbol here is plus. What is the precedence of symbol plus it will return? It returns, we already know that it is going to return 2. So the precedence of symbol, the value it is going to return is 2. So this function returns 2. Now less than or equal to precedence of top of the stack toss. So we have to check here. Now top of the stack here is what? It is, we are going to check that with top of the stack here is this open parenthesis. Now open parenthesis, when you check, it is 1, and if the precedence of symbol is plus, that is 2. So it's very clear that 2, and this precedence is going to return 1. This function will return 1 and this function will return 2. So 2 is less than or equal to 1? No, it is false. So 2 is greater than. So what happens? It will push, since it is false, it will push into the stack. So that's why what we are trying to do is we are pushing it into the stack. If you see here, since it is greater, we are going to push it into the stack. So plus is pushed into the stack. Now break, again it goes to the next symbol. Now this is, it goes break again, switch case. Now it goes to the next symbol. What is my next symbol? The next symbol is B. So it is very clearly written that whenever there is an operand, it goes to default. In default, what we have written? We have just said, now it is B. This is stored in postfix of J++. Now first it was J was 0. Now in postfix of 1, B is stored. Fine. This is, we have clearly it is mentioned here. Now this is 0 and 1. So directly it is stored in postfix. So whenever there is an operand, we are going to store it in postfix. So it is, if you understand the example clearly, understanding this program should not be difficult. Again, next symbol is operator, that is division. Now infix of 4 is division. So now it is division. So here we are considering division now. So in symbol division is stored. Now division we know it goes to which part? The case this operator again while. So every time we see this operators, it is these two statements are checked. That means precedence of symbol, it will check with the precedence of symbol. Now here, what is the precedence of the symbol here? This one, whichever is written in the column. So precedence of symbol will be checked with the top of the stack, right? So top of the stack, if you see the top of the stack is plus. Now division precedence is 3 and plus precedence is 2. So we clearly know that it is greater. So but here we have written as less than or equal to. 2 is not less than or equal to. So if you see here, 3 greater than 2. So 3 is not less than 2. So what happens? It directly pushes into the stack. Push symbol stack. So this goes on until we reach null. So next again see, we directly operand. Now the comes is whenever you see the closed parenthesis, it will pop all the operators pop and stores. It will store. So that's what we are trying to do. Now see, if you see the last one, infix of 6 is nothing but closed parenthesis. So here, while stack of top of the stack is not equal to this closed parenthesis. That means here it's very clearly we have shown that the moment you encounter this closed parenthesis, we are going to pop the top of the stack and store it in postfix. Next to top of the stack is plus. We are going to store it in postfix. So now we will continue this process until we see closed parenthesis, open parenthesis in the stack. So we are going to pop, but we are not going to store it in postfix. So this is what we have written very clearly. While stack of the top not equal to, say for example, you have like this. Assume that we have open parenthesis plus I have star and I have now one more division I have. So if you see here, star and division, okay, plus minus. So I have plus here. So if you see this, the moment I encounter this closed parenthesis, I'm going to pop here. So pop the stack, top of the stack, not equal to open until I see this open parenthesis. I keep popping and storing it in postfix. So that's pop and store, pop and store till this process happens until we see open parenthesis in the top of the stack. Then what we do, once we encounter, we will just pop, but we will not store. So what we have done here, we have just popped, but we are not storing it anywhere. So once break. So again, similar procedure starts, completes. Again, last is D. Now at the end, what happens is we are closing, since once you see the null character, it will close the for loop also. Now, whatever is left out in the stack, there may be a situation where it could be like this. See, if you see here, we have encountered null. We have encountered null. but still there are some operators on in the stack. So what we do, once we encounter null, we pop all the operators from top of the stack one by one and store it in Postfix. So this becomes the end of the convert IP function. So if you observe here in convert IP, we have called push here, right? Push, what happens? Character is hash here. Now first the it is incremented, top is incremented, and then you are going to store M here. M, that is hash, is stored in stack of top. So if you say, assuming that this is your stack and top is pointing here to -1. First what we do, first we increment. Now top is pointing here. After incrementing, you are storing hash. So this is, so every time you call the push function, first it will increment the top pointer and then insert the element. Similar with the pop, it is going to pop, that is first it will display and then it is going to decrement. So precedence symbol also we have same. So finally what happens is, from main function you're calling. Now you understand very clearly that we are calling push pop in case 1, right? We also in case 1, as well as we are calling pop in case 2. In this case, twice we are going to call, and once again push we are calling here. So in this precedence function only we are going to call push and pop. This is the complete program of the stack convert IP, that is converting infix to postfix.